First of all, thank you very much to Immersis for hosting both me today, but also this evening, because it's awesome. This kind of meetup is, I think, really important for to build communities. So thank you all for coming. Thank you for the people who've been here today and have stayed. I can't believe some of you have. That's amazing. So thank you for that. And I guess we'll get on. I'm going to tell a story this evening about a program, a portfolio program, a company I've been involved with for about about 4 years now. And it's about their journey towards microservices in some senses, and also their journey towards being a sort of 21st century, what I think of as a 21st century organization. I think stories are nice, stories are important, stories allow us to share our experiences in a safe way. My former colleague who's now at Facebook, Simon Stewart, he talks about the importance of stories for teams. And he came up with this idea of a role on a team which was a team shaman or shaman. So on your team you would have someone who can tell you the story of how things became the way they are. Right? So the classic, and this is from the old days, I'm most experienced in Java, and the old build tool for Java was Ant. And so you often over time you'd get these huge Ant files, XML hell, right? Just massive, hundreds and hundreds of lines, maybe even thousands of lines of XML. And someone new would join the team and they'd walk in and they'd go, oh my gosh, what is this? How did the build get to be this way? And of course the team shaman is there to sort of gather everyone around. Come on, come over here, and I'll tell you the story of the build. Right? Now that, I think, is a really important role actually in organizations, people who can tell you the story of things. And so I'm going to tell you on a story, it's not of the build, it's of a company called Compare the Market. They're an insurance aggregator. They've grown massively over the last, I guess, 6 or so years. They're really successful, by far the market leader in the UK. So what they do is it's quite simple as a business model. You're probably familiar with them, with this kind of idea, but essentially they sit as a sort of umbrella over lots and lots of insurance houses and offer, and will offer you the best deal for insurance of a different type. So it's a pretty simple business model. It's essentially only works on the internet with the World Wide Web, but they're pretty successful at doing it. So I will tell you their story. Now, the fun thing about this is it's a bit like a reverse startup story, right? Because when we arrived there back in 2011, they were very much like this, right? They had an IT department, they had group IT, everyone was siloed into these different parts of the organization, and literally everyone wore suits. The network engineers, the people cabling new machines, everyone wore a suit, a shirt, and a tie. Now, very traditional big IT kind of organization within a big insurer. And some years later, with some courageous leadership and some interesting decisions around things like technology, they ended up looking like this, right? They're this kind of awesome startup unicorn with fire and cats and guns, and you might recognize some of these slides from earlier, people who've been around today. And what's interesting about this idea of starting, rather than starting small as like a small startup and growing and scaling, going the other way and starting off as this massive IT department, this massive kind of besuited, slow, difficult to get things done IT department, and moving towards this model is it's going the opposite direction to most companies. And there's this kind of interesting, I guess, model. This is the probably adoption curve. You've probably come across this before. It's kind of meaningless. But if you think about the way most organizations work over their lifetime, what happens is you start, you innovate, you're in this mode where you're exploring, where you're trying to create new ideas, create new markets. But then eventually you end up in this kind of big, staid, laggedy, kind of cost-focused, cost-centric organization. So you start off that pure innovation, and you end up 50 years on, however many years on, in this kind of laggedy place where things like IT is a cost center. You treat developers or people as essentially resources. You go for the cheapest, You don't really want excellence, you just want bodies. And things like standardization, cost control, those are the key things you're looking for. And so this is where these guys were in Compare the Market. They're an internet startup. They are a startup, except they're in this organization acting in this way. Similarly, they have this classical split, right? Siloed development, siloed testing, siloed project management office, siloed operations, and then over across the yawning crevasse of doom, never the twain shall meet was the business. All right. On top of that, they had some interesting technology problems because over a period of time, as they'd sort of gradually tried to remove themselves from their previous DB2, kind of big mainframe insurance background, they'd started to try and build software in a more modern way, but they'd carried a lot of that legacy with them. So they were a .NET shop, in their case VB.NET. They were using, and they built out this typically three-tiered .NET application, right? So you have the database, a ton of Transact SQL in here, lots of logic. They had data services here, and they had a big sort of VB.NET web app at the top. And this is what we talk about in ThoughtWorks as what we refer to as a wormhole architecture. I did talk about this earlier, but some of the features that this sort of design, where you're running data services in one set of processes, in one process, a website in another process, then having logic in the database. Some of the features of this that makes the impact of change quite difficult to reason about. Changes to very simple things tend to ripple out across all these layers. So an example is if you use this tracer bullet idea, if I want to make a small change in the web app to say add a form field, then what you end up doing is have to change the web app, the data services in lots of places, maybe the DAOs or DTOs, need to change the APIs. I have to change some stored procedures in the database, and then I have to change the schema of the database and so on. So this kind of system tends to tight coupling and a lack of cohesion around the business. So that's, as I say, wormhole or concertina architecture. We talk about a concertina two-tier. So we've taken something that should be together and arbitrarily split them across processes around technical concerns. The other thing that was quite fun for them was so we ran some analysis tools against their code base, and they had they were using a homegrown code generation tool to talk to their database. Now this database back here, this database was a direct port of DB2, including all the DB2 table names in here. If you've ever worked with sort of kind of DB2 or kind of stuff on the iSeries and with RPG, you tend to have table names that are 8 characters long, with kind of A, F, C, 1, 2, A, B, or whatever it is, and each of those things mean a particular thing. So A means it's about, audit, and B means it's etc., etc. Horrendous, and it all ended up in here. So they had this homegrown entity framework, which wasn't the Microsoft Entity Framework, which auto-generated code in order to deal with this database schema. And when we ran some tests against it, it ended up, slow down. We came to some rough orders of magnitude estimates for how much code they had auto-generated. I think they had, we worked it out, it was about 2/3 of a space shuttle operating system in auto-generated code to talk to a database to sell insurance, which is quite a lot, right? About 400,000 lines of code is the space shuttle operating system, or was, because it's no longer flying. And they had about 260,000, 270,000 lines of code that was auto-generated just to talk to a database. It's kind of interesting how they got anything done. So the next thing we sort of looked at, so anyone here work with ETL tools, data warehousing? So they had this classic enterprise data warehouse down the bottom, right? We often talk in ThoughtWorks about having an enterprise data bucket. So you have this kind of like drip tray underneath your systems with holes in the bottom of each of your applications which drip into this kind of this bucket underneath. right? And then various jobs happen that transform it for various reasons. Data goes in the top, ETL does some stuff, and then no one has a real clue what the reports are for, what they mean, how often they're going to get them. And the problem is that change becomes quite hard in these sorts of environments, right? So especially when you plug ETL into the mix, and especially when you plug this idea of having siloed metrics teams or siloed data teams who manage the reporting, manage metrics. Also, they had a pretty interesting way of running projects, which was akin to playing snakes and ladders. So they had difficulties around their code, they had difficulties around the architecture, they had this really interesting thing going on with data and how they were transforming data. It's very complex, but they also tried to do work in the standard kind of waterfall way. Now, I've got an example of what I mean here. So this is a standard, maybe user story wall or story wall, and this is pretty much what happens in waterfall, right? People have come across this before, and we'll start again. And this is this transaction cost incurred because we think we're so smart we'll be able to specify everything up front, and then we'll throw stuff over the wall to the next group, the next functional silo, the next role-based silo developers who'll pick it up and just write some code. I mean, this is I'll design the system because I'm the smart architect. I'll hand stuff over to the developers. The developers will say, that's brilliant if only you lived in the real world that I live in, because this will never work. And they hand it back to the architecture team. The architecture team go, okay, well maybe I'll flex this, change this a little bit. Hand it back. The developers say, well that's kind of okay, except blue, not green. You get this kind of transactional handoffs between lots of different parts of your organization. So, being a consultant, I work for ThoughtWorks, which is a consultancy. I love the Magic Quadrant. We're all about Magic Quadrants in consulting. So, I'm going to use a Magic Quadrant broadly based around the ThoughtWorks Technology Radar quadrants. So, the techniques that they were using, tools that they were using, platforms and languages. And we'll be using this to explore how they change over the course of the next some number of years. Because when we sort of joined them, this was how they were looking. So they had this gated waterfall development process. They were building these wormhole or concertina two-tier architectures. They were doing project branching, feature branching. They were doing all this kind of design up front. That was an activity, and they had these siloed roles. From the tools perspective, it was, as you'd expect from a .NET shop, pretty much, VB.NET shop. Visual Studio, SQL Server, PowerShell, that was pretty much it. On the platform side of things, they were using the CLR and they were on Windows. And in terms of languages, VB.NET, T-SQL, tiny amount of C#. Not entirely sure there's robots speaking to me somewhere. Awesome. Robots, they're the future. And there was a bunch of developers who were working for them. They'd been hired as people to work in the startup environment, and they were just asking over and over, just this refrain: Why are we not doing other stuff? Right? Why can't we use other technologies? Why can't we use other ways of working? Right? So, our heroes start their journey. This is referring to them rather than us. So this is ThoughtWorks. I don't know if you'd recognise ThoughtWorks before. This is what we all look like at ThoughtWorks as consultants, as you can see. Yeah, consultants. Hell yeah. This is us. So actually ThoughtWorks is interesting. We're a bespoke software engineering consultancy. We've been around about 25 years now. We've got a bunch of fairly well-known people who work for us. We don't look like that in general. I feel overdressed today. I had to apologise when I turned up, because I was wearing a shirt. This is not something normally I do. But essentially, they are some consultants in. The story was really that they had an interim CIO. So if you've ever come across that sort of role, generally what happens is the current CIO or CTO or board member either goes to get a better job because they've done something great, or goes to get a better job because they haven't done something that great. And you get an interim in the meantime to sort of settle the ship, stabilize things, essentially to take things forward. And so they got this interim CIO, and he said, right, well, what we need is a report. Well, we need consultants to tell us what's wrong,
and then I can hand the report to the person who comes after me. So essentially, that's what happened. They hired ThoughtWorks. I went in there with a few other people, and we wrote a report about all this stuff, right? So we talked about silos, we talked about waterfall, we talked about project branching, we talked about the technologies that they were using maybe being suboptimal, we talked about the architecture they were using maybe not being fit for purpose, etc., etc. Much as you'd expect, that went down. How do you think that would go down? Pretty badly. I sat with the board and I sort of talked through this stuff, and it's classic things like not communicating the vision and so on. I should point out that the great thing about that organisation is actually when they sort of settled and thought about what we'd been talking about, they decided decisively to change. And this is the actual really cool thing about Compare the Market and why I'm still involved. I was actually there last week on my own time to facilitate a retrospective for them, because they are an awesome organisation and they've come a hell of a long way, as you'll see in a sec. But at the time, they had this big IT kind of organisation's reluctance to change. So they took this report. Can anyone guess or the definition, what word this is defining? And I appreciate it's in English. So the measure of a body's resistance to changes in velocity. This is exactly inertia, right? They had a ton of inertia and different types. They had this kind of real organisational inertia. Right. So they were going in a particular direction because they had been for 50 years as a big, well-established IT organisation and insurer. And then they had this sort of technical inertia, which had come from this legacy of having DB2 and other technologies. So how do you start to overcome some of this stuff? How do you start to overcome this organisational inertia in that sort of environment? Well, as I say, they had incredibly pragmatic, courageous leadership, and they had a bunch of developers, a bunch of engineers who really wanted to make a change. One of the first things they did, interestingly, was build a new office. So they actually took themselves away from where they were. They said, we're not actually going to live, as it were, in this environment anymore with everyone else. We'll get some investment, and we're going to go and build a new office next door, and this is where the startup will be. So they kind of separated themselves off. And this is a classic example of what happens when you apply Conway's law. I'll come to that in a sec. Because they took themselves away from the rest of this big sort of quite staid organisation, they were able to isolate and make changes more effectively. Now, in the report, one of the first things we talked about, one of the first recommendations we made, which will be, I think, potentially familiar to people here who've been here today, is this idea of product teams. So moving away from the idea of short-lived projects, which is the classical way to run organizations, right? It's the classic way when you organize around utilization and efficiency. We want everyone utilized 100% of the time. There's an example, I have this great example of the kind of weird behaviors that sort of thing drives. I was at a music retailer some years ago, and it was interesting because I was talking to the product management team, the project management office team, so all the PMs and the head of the PMO, and they were saying it's the problem we've got is that we haven't got any time to do more stuff. All the developers and testers are busy 100% of the time. Well, that sounds pretty awful. So we went and talked to the developers in teams on their own without management around. And we said, so what's going on? And they said, well, the problem we've got is that we haven't got anything to do. Right? We're bored. Right? What do you mean you haven't got anything to do? You're bored. So honestly, we work probably maybe 30% of the time. We're actually working on writing software. And we were trying to work this out, what was going on. And the thing that was going on was timesheets. Right, because the project managers were saying you must fill in a timesheet and allocate all your time to a project, and that was how the developers were being measured and whether they were working on a project. So of course the developers would allocate all their time. Right, so I would say, yes, I've worked 8 hours today and 8 hours yesterday and 8 hours the day before on this project. So what the project managers saw was 100% utilization, but what the developers saw was I'm not doing anything, but I have to fill the timesheet in. It's this kind of crazy mix-up when you start to focus on utilization. And there's also this kind of when you extend that model to running short-lived projects where you get a group of people together to work on something, they build something, throw it over the wall, disband, go off and work on something else. So one of the first things we started to talk to them about was this idea of long-lived product teams. The new thinking is this idea of service teams, of service-aligned teams. Not microservices. This is a different concept. But product teams, right? Building out independent product lines. So rather than have this kind of model where you have testers and developers and ops and project management office, and the way work would get done is I have a feature, I'll bundle in a few more. The project manager will get a couple of developers and a tester. If you're lucky, they'll work on it for a bit, and then they'll throw it over the wall to operations, and then they'll throw it back because it's buggy, and then they'll throw it over, etc. They said we'll have these long-lived project teams organised around our lines of business, around our product lines. And they were cross-functional, so not in terms of having a person who was a tester, but of having all the different roles required by an engineering team to get their software from idea into production. They were all represented as part of this product team, essentially. So you had some product management business people, you had some development, you had some product management role, you had some development roles, and you had testing and so on. So cross-functional teams organised around products. So far, so 2000, right? We also implemented. So just who works in this way in this room? I appreciate that there's a bunch of people here who would say you don't need anyone apart from developers because everyone else is completely superfluous. So if I said if you got rid of all the other roles, maybe a few more, I don't know. But this is the way most organisations have been moving, organising around products rather than projects. Most. The 21st century organisation is moving, I should say. So the next thing is moving on to agile software development. Now, this is the other thing we recommended. Now, this might sound like this is 25 years old, because basically it is. 20 years old, because basically it is. But simply, what does agile software development look like? Well, the idea is you focus on one thing, and you get getting an idea from concept out into production, and try and work out how you can minimize the waste inherent in that process. Agile software development, pretty straightforward, I think. The other thing is that they took the decision to start small. And I think this was a really interesting thing that they did. So rather than say, we've got this big problem with our technology, with our infrastructure, with the way our teams work, with the way our projects are structured, they didn't have some mandate from the leaders that said, now everyone reorganize into all these different product teams. They said, what we're going to do is we're going to try something low risk, start small, and try and build some trust. All right, try and see if it works. Try and run an experiment in our environment to see if we can make these sorts of structures and technologies work. So actually, rather than do anything to the old legacy system, when they had a new product to build, they built it off to the side. In this case, it was a money insurance product. Not money insurance. It was money aggregation, so comparing different types of credit cards. So, which is quite a nice way of getting going if you want to get going on this kind of thing. And they also started to adopt a service-oriented architecture. And in their case, again, this was oriented around, see what I did there? This was oriented around separating out their insurance products into separate lines, separate product lines of business. And crucially, taking the data with them. Now, when most people hear service-oriented architecture, they hear enterprise service bus. All right. Well, I'll come on to this in a minute. But rather than go that way and have a big bus with lots of smarts in the middle, they moved the other way and started to rely on very lightweight messaging between components. So, an SOA with this concept of smart endpoints, the logic in the services, smarts in the services, and dumb pipes rather than smarts in a big bus in the center. So that was basically their first attempt, the first project organised around product team, using a new set of technologies and so on. So, as I say, it's kind of interesting. Given where they were, they started introducing these different techniques. They started doing TDD. They started using agile development methodologies. They introduced the idea of product teams. They introduced ReSharper. Now, if anyone's worked in C# without ReSharper about 4 years ago, I pity you, because obviously Visual Studio has come on a long way in the last few years. They moved to Git, away from TFS, the terrifying tooling that Microsoft put together for CD, and they moved away from that towards GoCD, the continuous delivery server. And they introduced a new language. They started writing code in C#. And that was actually a massive deal, right? Because they had a bunch of people who'd never come across that language before. They'd been writing exclusively in VB.NET, and they introduced C# to them. And they'd been hiring people for years and training them on VB.NET on the basis, as I said earlier, that they have this lowest common denominator approach to hiring. So we'll just hire random people, train them in VB.NET, they're an engineer. Now that was the big IT approach, right? And then suddenly you take these people and say, no, C#, dudes. This is a very different thing. As I say, this has completely changed, and it's actually remarkable, the stuff they're doing, both them and the wider organisation now. So the next stage, the next set of things they adopted. So they took on this idea of separating the products out. Well, we've made a success of this this low-risk, small thing we've built. So can we separate these products out? So they addressed splitting up the monolith, which they did. So they started taking each of the product lines out until they ended up much later on with independent product lines around the different types of insurance, with duplication of functionality, duplication of data, all this stuff across these. And crucially, this idea of having cross-cutting capabilities. And each of these are a completely different bounded context in domain-driven design terms, with separate teams running them. Which brings me on to Conway's Law. So Conway's Law is kind of interesting. It basically says there's a quote in a sec. But it basically says if you've got some software, then the software you build will look like the organisation that builds it, essentially. Right? I'll come to that in a sec. So what they did when they organised these teams around the product lines, they started reinforcing the boundaries of the systems that the teams were building. Right? Because it's harder to communicate across these boundaries by talking to people. The bandwidth for literally human-to-human communication is lower across these team boundaries. It started to reinforce the architectural, the system boundaries of these bounded contexts, which is kind of an interesting idea. As I say, this is the original quote from Melvin Conway. Organizations which design systems are constrained to produce designs which are copies of the communication structures of those organizations. So if you have a DBA team, and you have a middleware team, and you have a web team, what you're going to end up with is web, middleware, database. That's what that says. But if you organize around, if you say we've got product teams, right, we'll put teams around the products, then you'll end up with product line-based designs. They reinforce one another, they're mutually reinforcing. As I say, so each of these teams, because of the different, it's an information theory thing, essentially. So Conway's Law. They also, and this is maybe why you were here, decided at this point to adopt microservices, essentially. If you haven't come across this, this is the shameless plug for an article I wrote whilst on a week-long sleepover at Martin Fowler's house, and that is true. In that, we talked about a bunch of the things, the characteristics that we were seeing in the wild. And actually, a lot of those characteristics are reflected in the journey that Compare the Market went on, as well as many others. But it's not just about splitting stuff up into services. It's about taking on things like this decentralized data management, smart endpoints, products, not projects, and so on. They adopted a lot of this stuff. Yeah, this this is a British comedian called Alexei Sayle, who everyone everyone tells me I look like him. So that normally raises a laugh in the UK. It's anyway, cultural and all that. Yeah. The next thing they did, which is interesting, because they had these product teams, because they were decentralizing decisions about design to the product teams. Right? Each of the product teams could decide the best approach to building each product out. Right? And so, as an example, the first product team decided to use event sourcing. Specifically, they decided to use CQRS, which is a command query responsibility segregation, the pattern to build out their first product. It's an interesting pattern. If people have come across this or used it or implemented it, it's very common these days in the .NET world in particular. But essentially what it says is you separate the different aspects of your system into a write side and into a read side. So anytime you want to write data, you write to the write side and read data to the read side, you get from the read side. But the way that data is stored is kind of interesting. So usually what we have, if you have, say, a relational database, and you have a user represented in the relational database, you'll have a table, and you'll have a number of columns that would refer to the properties of the user. First name, last name, title, address line 1, address line 2, phone number, etc., etc., etc. Right? And if you write an update to that user, if you make an update to that user, you change directly the value in that column. Yeah? So you'll say, I'll overwrite address with the new address data. And if you read, you just read that current state back. With CQRS, you don't store state in the same way. So state is stored as a sequence of events, and the current state of the user would be essentially a left fold over all the events that you've got for a user. So say the first time a user is created in the system, you might have a user created event, which might be this yellow thing here. That might be user created. Right? And once that event is stored, a message is sent over to another database which stores the current user state. And then when you want to read the current user state, you read from this database. The next thing that might happen is a user might change their address. And another event is generated and stored in here. So you have user created, address changed, and another update is passed and the address is changed over here. And the key thing is with this is that the events themselves are the source of truth of the current state of the domain, of an object in your domain. I appreciate this is a 101 overview of CQRS in approximately 45 seconds, so apologies for that. But the key thing to remember is that you can completely blow away this database. You can blow away the current state, delete it, completely destroy it, and completely recreate it by replaying all these events for a particular object. That's the design they chose. It's quite complicated. They had their reasons, and of course, one of the things that happens when you allow teams to make their own decisions is sometimes they don't make decisions that you necessarily agree with, but hey, you have to run with that. But they started to move to this CQRS pattern. That's represented by rabbits because we were using RabbitMQ as the messaging bus. Fluffy rabbit. They also started to layer on lots and lots of monitoring, and that gave them tons of really cool and unexpected things started to happen because of that. I mentioned that this is CQRS. This is Greg Young, the guy who came up with the pattern, looking very dapper. This is another definition: understanding of a specific cause and effect in a specific context. Insight, right? This is insight. What CQRS gave them, or this event-driven approach gave them, is so much more insight into how their business was performing than they'd ever had previously. And that allowed them to make some much more high-fidelity decisions about where the business was going to go next. There's an example, I was on the customer account team, the My Account is the cross-cutting thing. And we started pushing all these events that were being generated through a very simple algorithm that totted up how much money we were making from our application per day. Really simple. It was just a little node service that just listened to Rabbit. Every time an event came through, we summed something up, and we could plot it on a nice graph. And as soon as we started doing this, the behavior of the development team completely changed. Suddenly, there was real money involved in what we were doing. Suddenly, we could go to this thing and say, it's 4 o'clock in the afternoon, and we've made how much money today? I really want to make sure that the code I'm writing is not going to take this thing down, because we can see per minute, per hour, the actual increase in cash and revenue we're generating for the company. It was a really interesting insight that we got in terms of business insight. But we also got these interesting operational insights. We started being able to measure all sorts of things that we weren't able to previously. An example would be producing reports that evening, which previously the data warehousing team took up to a month to create. So we could do trading reports for that day then, rather than have to wait a month for all the models to be updated, the ETL tools to be run, the new schemas, star schemas to be calculated, etc., dimensions to be calculated, etc., etc. And suddenly the business had much more information about how about how to steer the direction of the company. Business insight, operational insight, as a result of these slight tweaks and changes in the architecture of the system and how their teams were organized around it. So in Graphite, use a tool to do this stuff. That's what this slide says. Maybe not Graphite, it's quite tricky. Grafana on top is quite nice. The other thing they were able to take advantage of is this idea of using the right tool for the job. So previously, they had to use a particular, thou shalt use VB.NET, thou shalt use SQL Server, thou shalt. Because they'd broken up this big thing into much smaller things, they could make more sensible decisions about each smaller thing. So they could say, maybe a SQL Server database isn't appropriate for this particular use case. So the right tool for the job. It's that old line, isn't it, about it's that old line about nails and hammers and stuff, which I can't remember. So, just saying, it's been a long day, but come on, it's been a very long day. So what do I mean by right tool for the job? So one of the things, so we have this CQRS pattern going on. The actual stores that we were using to back our events, we started to use Mongo database, all right, for that, the MongoDB for that. Because it's a document-oriented database, the events we were generating were essentially documents. It was a perfect fit for the for the problem that we had. Previously, that we wouldn't have been able to do that, or the organization wouldn't have been able to do that. But because they were able to break these things out, devolve responsibility to the teams, each team could choose the right thing for them. Dan North talks about microservices as being replaceable component architectures. So the thing he likes and the thing he emphasizes is the fact that if you break things out into smaller bits, you can replace parts of them individually for various reasons, including when you learn more about a problem you might have, an opportunity, a business opportunity you might have. And in our case, this kind of happened where we learned a bit more about our operational reporting needs. Our business reporting needs, and we started to replace things like the big data warehouse with parallel systems that actually they're not using Neo in this case. It's much more on the Hadoop side. So they're in that Hadoop Spark ecosystem. But they could do that because they'd broken things out. They were able to make decisions about parts independently. So the right tool for the job. So this has been quite a long journey that these folks have gone on. I'm going to briefly summarize, I guess, from where they were to where they got to. This is what they ended up doing, and the first time I did this was, I don't know, over a year ago now. So, on techniques, they were in product teams, microservices. They were using this API stability onion idea, if you've come across that. They were using test-driven development, infrastructure automation. They were applying Conway's law. Agile software development, actually, a lot of their teams moved to sort of more lean approach, a Kanban type approach, and continuous delivery. On the sort of tools side, vastly different landscape, right? So where previously they were just in the land of Visual Studio and TFS, now they're able to take advantage of a bunch of tooling. So they're using things like Mongo, they're using Cubism to do graphing, a whole bunch of other tools. Platform side, they're polyglot, right? So they're on Node for various things. They're using HDFS, Linux, Windows, and they're still got a lot of stuff running on the CLR. And then languages, well, where it was T-SQL, VB.NET, they're taking advantage of a whole bunch of stuff. So F#, they're using reactive extensions, a bunch of JavaScript, actually some Erlang as well. And this is a company, as I said when we started, was this very, very staid IT organization that was really successful, but was finding it very, very hard to scale. And this is where they got to after a few years, which was pretty cool. And actually, since I put these slides together, I saw them last week, and they're on the next step now. They're on the next part of their journey. They're talking about how can we, now that we've sort of we've got to a particular point on our journey, how can we start to break up the organization to be even more effective? How can we introduce more technology to be even more effective? So, I mean, I was there for about, on and off, 4 years, and we learned some stuff along the way. JavaScript developers in the room? Yeah. Just checking. There's a bunch of stuff, right? So the first thing we learned is that events, if you can build an event-driven architecture, it rocks for insight reasons. It genuinely does. The stuff you can do when you've got real or near real-time events flying around your system is, or maybe you move to a reactive version of control version of it, whatever. You get an awful lot of insight from it. But they also suck really hard. If you get the granularity of the events wrong. So the example I gave earlier, if you do things, if you have an event which is user created, user address changed, user telephone number updated, blah blah blah, you have to manage the contracts of all of these events. Now, anyone in the room love managing API contracts? Hands up. Yeah. Obviously, the API contract guy does. But managing API contracts in general, sucks. Changes to them suck. And if you've got tons and tons of events, that's essentially what you have. You have contracts, and working with lots of them becomes quite difficult. On the other hand, events are awesome, as I say, right? So if you can limit the number of events to business meaningful contextual events, in more of an event-driven way rather than a CQRS sort of way, you can get huge amounts of benefit. Taking on the new language thing, that was actually pretty scary for a lot of people. And it took a lot of people a long time to come up to speed. And I think this was because of this approach they previously had of lowest common denominator. Saying that, all the people they have, I've been back there recently, as I say, all the people they have are now kick-ass C# developers, right? Which is an amazing, amazing thing, but it's taken them a long time. Anyone seen the video, the WAT video? Yeah. I haven't got internet, otherwise I might just put that on. Because that is, go look up WAT JavaScript, because JavaScript, it was really, really, really quick to get stuff going, we found, but actually we really needed to bring expertise in from externally to help us when we were starting off building Node services. We found that quite tricky, just because of the heterogeneous way that you can do stuff in JavaScript. People were just running off in all sorts of different directions, a bit like Scala land. API design, because of events, because of other things, became really, really important. So we actually spent more time, I think, on API design than you might think, or than you might normally do. I think in my experience, a lot of teams' approach to API design is there's an object, let's turn it into JSON. that's my API, right? Whereas when you've got services communicating via these events, we spent quite a lot of time trying to understand what the events looked like, what the different APIs were. Yeah, this is to do with events again, but asynchronicity can suck again. So we ended up with lots of tests that had like wait 10 seconds in it, or wait until 10 seconds is up. And that gets really tedious and leads to kind of really flaky and flaky builds. And that's not great if you're writing code. And this is because the way that system works, you pop an event onto, you drive a website, that would cause events to trigger, which would go onto buses, which would then trigger other things, and then eventually you'd be able to read on the website again. So you'd have to wait whilst all this propagation happened, and hope in 10 seconds time that you could, or so however many seconds time, that you could actually check that the test, the assertion of the test asserted a valid result. It's fine, end-to-end test, they kind of worked, but at the same time, it was tedious. And siloed metrics suck. Yeah, I think I covered that. Oh, and finally, just saying DevOps doesn't make it DevOps. We've got DevOps now, right? DevOps is actually, this kind of move towards build it, run it, fix it, operate it, whatever it is, which they've moved towards. That caused a lot of angst amongst a lot of the, amongst people in the organization. Where does my job go if we move to a build it, run it team? What's my responsibility these days? All these sorts of questions start coming up, especially as you move to being cloud native. If I'm a network engineer, what does that mean if we're cloud native and Amazon handles all my networking? It's quite scary. So yeah, change takes longer than you think. This is actually the month we started, so it was April 2011. They're not finished. They will never be finished. In the same way that lots of other organizations, 21st century organizations now understand that you're never done, right? You can't just build something, throw it over the wall, and move on to the next thing. You continuously have to build, you continuously have to develop, you continuously have to improve as you learn new things about your systems, about your domain. So we're never done. At that point, I'm going to have some beer. We can maybe do some questions, and then we can go to the pub. How does that sound? Thank you very much. Questions? Who are you? So I had this, we did a live Periscope. Apparently it's a kids thing. We did this Periscope of a talk I did. And at the end of it, we had a live Q&A on Periscope. And the very first question on that was, who are you? Which I thought was brilliant. So I'm James, hi. Questions, anyway, if you've got any questions. Yeah.
Question on the topic of if you have a team who can decide on the tools they use, they will choose the right tools. Critique to that is that that might work very well in a case when you have a pilot and you pick the brightest and most enthusiastic people. But in my experience, maybe most of the developers, they actually prefer that you tell them what to do with what tools, and how can you change that so that they will be able and active to pick the right person.
So how do you get around this fact that people just want to be told what to do? I don't know. Hire different people. No, I mean, that's a really hard question to answer. Yeah, I'm not entirely sure how you get around that. It's
Okay, let me put it in another way. In your experience, if you empower a team to be able to have the freedom to have their say in such decisions, with time will it end up that they will actually have the need to change things?
So again, so no. So I think this is about levels of experience, right? So my experience has been that when people come into the industry as graduates or whatever it is, then you become very focused on a small part of the problems that you're trying to solve, right? So you end up focused on the next line of code. You end up focused on the next task you've got to pick up off the wall, that kind of thing. As you gain more experience, my experience tells me I started to see outside that kind of the confines of just the next line of code, the next task. I started to be more interested in why are we doing this? Why do we have to write this particular software in this particular way? And as I got more experience again, I started to be interested in, well, why this technology? So I'm not sure if it's I guess a black and white. Developers like being told what to do. I think it's maybe much more nuanced in the sense that developers, as they grow and as they become more experienced, especially if you give them time and don't push them down some project management or operational leadership route, will gradually pick up this kind of idea about choosing the right thing. But I think it's experience-based. It's a skill. It's a skill choosing the right technology, and it takes time to develop skills. I think maybe that's what I would say. Any more? Yes.
You mentioned that pattern when you store your data in a read and the write part, but I couldn't catch the name. How do you?
Yeah. So that was. Thanks for the question. So the question was when I was talking about event-driven. That was event sourcing. It's called, and you have specifically CQRS, command query responsibility segregation, and the pattern with that is you have an event store which holds the sequence of events related to a particular thing. So if it's a user, it's when the user was created, it's when changes happen to the user, maybe even when a user was deleted, although generally you wouldn't have that, maybe. And then the other side of it is essentially they call it a projection of your current state. So in the relational database sense, you've got a relational database with a table with the current values, the current state of, say, a user in it, but that isn't the source of truth. The source of truth are the events, and that current state can always be recreated by replaying all the events related to that user. And so writes happen into the source of truth, the system of record, the event store. Those events are propagated out to other systems, including different projections. The idea is that you can have different projections, different current states, depending on the usage that you want to put them to. So a website might want to read a user that looks in a particular way. So it might want a particular representation of the user and its data. Your, say, data warehousing system might want a different representation of that data. So you can project, this is why it's the projection, you project those events into into a state that your other systems want to see. So you might have a projection for mobile, which is much less data in it than the projection for the website, say. Which might have less, again, than the projection for the data warehouse, which wants everything. So it's kind of an interesting approach to software design, which is very useful in a lot of cases, and sometimes, like anything, can be overused, I think. Go and look up Greg Young talking about event stores and CQRS, because he's got tons and tons of stuff on this, and he'll probably. I'm surprised he hasn't phoned me already to shout at me about that description, because I probably got it very wrong, but never mind. Actually, so it's interesting because this is not a sales thing, so I don't want to sound as if ThoughtWorks is amazing, right? But we are amazing. No, so we've got an interesting model compared to a lot of consultancies. So a lot of consultancies' model is that you sell initial work, potentially at a loss, right, on the basis that you win support contracts, right? Because the revenue stream from support contracts is is massive, right? This is where the hundreds of millions of dollars or whatever it is goes in terms of big IT, big government spending and all this stuff. Now, we don't do that at all. In fact, we debate probably once every 6 months whether we should ever have whether we should even offer support, because we don't believe that's the right model. We believe the right model is for us to come in, co-sourced and work together with a team to deliver stuff as partners, and then when people are up to speed, we move out, we leave them, right? So, and that's exactly what happened in this case. When we stopped being engaged day to day, it was because we got to the point by pair programming together over a period of 2 years, 3 years actually, by just working together and realizing that we weren't going to be delivering as much value as we might have done if it was a team of people who knew all the technology and the practices, but we took on the extra, the business took on the hit of delivering slightly less value so they could skill up their people over a period of time. And so that was really, it wasn't so much around going off on training courses and workshops, although there was some of that, but it was more just working with more experienced people, pair programming over a long period that brought people up to speed, I think. Yeah, that makes, yeah. Did I do the sales thing? Well, awesome. It's my colleague over here. Gareth.
Okay, so actually, you put in developers with their inter developers together, and they were pair programming, and this was fine for both of them. Okay.
Yeah. So hang on, let me go back to
It's not bad.
this thing. So when we had the teams that were looking like this, each of these teams was co-sourced for a period between Compare the Market and ThoughtWorks. So we'd have someone playing the quality analyst role with a hat on, and shadowing or pairing with a quality analyst from Compare the Market. Similarly, we'd have a PM doing the same thing, and our developers would be pairing every day. So that would be, and then this is a model we've used quite effectively. So you get people who are able to do this, and then what you get to do then over a period of time is that when these folk are kind of all good and we're up for this, you can split and seed. So you can use these people to actually then, as force multipliers, like a virus. They spread in the organisation, repeating the love, as it were, or something. Yeah.
One of the really cool things that Compare the Market did was they called out enablement of their employees as a deliverable, and they prioritised it at the same level as software. So they were just like, we don't want to buy software, we want to buy software, but we also want to skill up our people.
Yeah.
And because it was recognised in the contract as a deliverable, it meant we could have conversations like, okay, well, you'll get the feature slower, but you'll also get good people. And that was a really, really cool move by them. I wish more businesses would do that.
And very exciting for their employees, right? Because suddenly they get to work in all this new stuff. Suddenly, it's, with people that they're going to be working with. But it's difficult because if you think about this as a process of never being done, then you can look at the mistakes you made in certain technical aspects of architecture, or so for example, CQRS in some areas really didn't work out. The granularity of events, I think potentially we got quite wrong in certain cases. We didn't split the domain up necessarily how we wanted. But because they've got this vision that actually we're not, once we build some software, it's not finished. When we learn more, we'll change it. Even though they were mistakes, they were great learning opportunities to move to something that's more stable and better and more fit for purpose. So yeah, maybe some of the things like that. JavaScript sucks. Just saying.
No problem.
CQRS is a difficult pattern to understand. Conceptually simple. When it comes down to the implementation, there are so many moving parts that it becomes quite complicated very, very quickly. An example would be, so if people know much about distributed system design, you get into all kinds of complications when you start thinking about network partitions. So if I go back to, so in this, right, so we've got a couple of databases, we've got a couple of services, and we had an event so a bus, basically Rabbit, which was propagating events from the event store into here. It's all great, but at the same time, when you start thinking about what happens if there's a partition in the Rabbit cluster, right? When Rabbit split brains, how does this overall system work? You know, you start not being able to read your writes, right? Because you're not getting events propagated over here. What happens when you want to scale up elastically in this system? If I want more than one of these, and the partition only involves, it only involves a single node out of a 4-node cluster of this, but also it starts to get very complicated very quickly. Fortunately, they had some very talented sort of infrastructure-y software, solution architects, whose essential job was to write lots of tests, write lots of performance tests, understand what the characteristics of this system would be. And we actually had, so this was eventually consistent, right? So you could only read your write after a number of milliseconds, because the event has to be stored, put onto the bus, propagated to the read store. At that point, it's available for reading by the website. There's a finite length of time it takes for that propagation to happen. Well, smarter people than me just put a nice little tool together that would show you real time what that time was. So they had, so you could run soak tests and work out that actually this was only like less than 30 milliseconds in terms of propagation on average. Which, people can't do anything in 30 milliseconds. I can't blink in 30 milliseconds practically. So in terms of the eventual consistency, it was kind of okay. But we only did that afterwards, after we went, latency is a thing. We better put some stuff in place to handle this, So yeah, there were all sorts of difficulties, but I think the key thing was that they pushed through them. As they learned new things, they applied that learning, and I think that's maybe a lesson we can all take, because it certainly wasn't. I was just a small cog in this team, in one of these teams. As I say, courageous leaders, talented software engineers who wanted to learn. So, I do ramble when I answer questions. Have you noticed that? Any more, or should we go to the pub? Pub? Please, pub. It's been a long day. Pub? Bar. It's probably a bar. Yeah. Bar! I'm more than happy to answer more questions. That's fine. Or we can have them in the pub. Yeah.
There's an architecture where one team is developing something that could be a plugin, but the whole application is wired together horribly. Is there a way out from that? So, because you can't blow up the whole application, simply other parts of the company would say, we have to do business. We don't have 2 years to blow everything apart and build up again.
Did someone just mention OSGI? I don't know. No, that was a bad joke about Java land. No, so I guess to repeat the question back, is there a way of isolating yourself in building one part of an application from the rest of an application? Was that where you were going? If you're building a plugin on the side, is this in the same process? Yeah. So yes, there is, I guess. It involves extra work, I would guess. But you can use the same sort of techniques that you would use between two systems. That you can use that in process as well. So an example might be, okay, so one of the reasons we use messaging, document-oriented messaging, is to decouple parts of our application. And in general, what we do is we say, okay, we'll have this message bus, and we'll this thing will put messages on, this thing over here will read messages off. But of course, that's a sort of external physical abstraction over something you can do in memory, in process. So if you're in Java, there's a whole bunch of queues you could use in memory to provide the same decoupling. So yes, there are definitely approaches you can take, but they add extra complexity into the solution, I guess, that you're going to deliver. So you can pop stuff onto an in-memory queue, and then another process can other threads can pop those things off, which means those threads are decoupled. Another example might be circuit breaking. So this is a technique you use between two external processes. If that thing over there doesn't work anymore, then break the circuit. Open the circuit, stop calling it. It becomes slow, don't talk to it anymore until it's fast again. But you could do that, you could have an analog of that inside in your process. I've no idea what it would look like. But yeah, I mean, these are just patterns. I think you can use them internally or externally. So yes, it's not the end of the world. And any more than that is at normal consulting rates. Just saying. Thank you all very much for coming, and thanks again for hosting. It's been brilliant.